Hello everyone. So in this assignment, you guys are going to be looking at how to find an angle when it's missing using trig. Right? There's some notation I need to show you quick to remind you. If you guys had 2/3 raised to the -1, this -1 means take the reciprocal. So the answer would be 3/2. If you had 5 to the -1, it says take the reciprocal, which would be 1/5. A -1 as an exponent means take the reciprocal. It's unfortunate that they don't have a different notation for what I'm going to show you, but it looks like they're using the -1 as an exponent. Now, first off, check this out. You have a square and a square root on the same button. They undo each other, right? They're inverses of each other. They're not opposites, they're inverses. So for example, if you guys had x squared is equal to 11, and you want to solve for x, you would square root both sides. Okay. X is equal to plus or minus the square of 11. If you guys had the square root of x is equal to 11, you want the square root to go away. So you do its inverse by squaring both sides. A square and a square root undo each other. A square root and a square undo each other. So you have x is equal to 11 squared, because these cancel out. They undo each other. Now going back to this one for a second, would you guys agree it would be absolutely goofy to divide by the square root on both sides? They don't make the square root symbol go away by dividing. That it's not logical, it doesn't work, it's not correct. Okay? You'd have to do its inverse, which in this case was squaring the square root to make it go away. And if you did it on the left, you have to do it on the right. Okay, what does all this have to do with fractions and an exponent and a -1? Okay, like I said, it would be great if they had a different symbol for this, but they don't. So here goes, hold on tight. You're asked to solve this problem, and when you're looking at it, again, use SOHCAHTOA words. From this angle's point of view, this is the adjacent side, and this is the hypotenuse. Using SOHCAHTOA words, adjacent hypotenuse, that's cosine. The cosine, again, I hate using this variable, but I'm going to do it. I really don't like using x as a variable, but here goes, meaning in a trig function. In pre-calc, I think you guys will start to understand why. Okay, here goes. Equals the adjacent side over 9.9. Now, to solve this, I need to make cosine go away. Just like this example I gave you here, it would be goofy, it would be incorrect to divide, by the square root. You can't divide by the square root. You have to do its inverse to make it go away. Same thing here. This isn't held by multiplication. I can't divide both sides by cosine. That doesn't make sense. No more than it makes sense here. I can't do it here. It's not held by multiplication. I have to undo taking the cosine of the left side. And how you undo that, and this is where I was saying I wish they had a different notation. I have to both sides, because if I do it to one side, I got to do it to the other. I have to undo cosine. I'm going to show you on the calculator. Notice the things that undo each other are paired on the same button. Well, what's paired with cosine? It's little cosine with the -1 as an exponent. Okay? That's what's going to make the cosine go away. And this is pronounced inverse cosine. This is pronounced inverse cosine. It is not the reciprocal. Like I said, I wish it had a different notation. It is not the reciprocal. It is the inverse of this. This undoes this. This one would be undone by squaring. It's what undoes the square root. I did it to both sides. So here, what will undo that is the inverse. Sorry, that looks like a 5. If I do it to the left, I got to do it to the right. It's not the reciprocal. These are inverses. They cancel out. So I have x is equal to inverse cosine of 1.4 over 9.9. And all you have to do to type it in your calculator is to get that blue, I hit the second button. There's the inverse cosine. And you just type in 1.4 divided by 9.9. Enter. And it says round to the nearest tenth of a degree. There's the nearest tenth. That's bigger than, or 5 or bigger, so it's 81.9. X is equal to 81.9, and you need the degree symbol because you're solving for an angle in degrees. You guys will learn later on when we do radians, if it doesn't have the degree symbol, it's not, it's measured in radians. Okay? Now, in the software, Delta Math, I don't think you guys need to type the degree symbol. I'm just letting you know, just be aware that when you're writing it, you really should have the degree symbol. Okay, let's go to this one. So I'm standing on this angle. This again is your adjacent side. This is your hypotenuse. Right? Setting it up, adjacent hypotenuse, that's cosine. The cosine of x degrees is equal to 26 over 95. I want cosine to go away, so I'm going to do the inverse cosine on both sides. Inverse cosine, and that's how you say it. You don't say cosine to the -1. You say inverse cosine. That's how you pronounce this. These two cancel out, so I have x equals inverse cosine 26 over 95. And again, you just grab your calculator and type it in. Come on. Inverse cosine of 26 divided by 95. Enter. Round to the nearest tenth. Oops, this says round to the nearest degree. Okay, so that would just be 74. X is equal to 74 degrees. That's a degree symbol. Okay, let's try the next one. All right, you're standing here. SOHCAHTOA words. This is your opposite. This is your adjacent. Oops, sorry. Hypotenuse. Whew, very bad. Opposite hypotenuse, that's sine. So the sine of x degrees is equal to, put a square symbol. What am I thinking? X degrees is your opposite side over 8.8. Don't cross multiply or anything like we did before. That's not what you're doing. You want the sine to go away. So I'm going to take the inverse sine of both sides. If you do it to one side, you got to do it to the other. These two things cancel out. X is equal to inverse sine of 6.4 over 8.8. You just grab your calculator and type it in. Second sine, there's inverse sine, 6.4 divided by 8.8. And again, I've been doing it, but you don't need to close that parenthesis. If nothing else is coming, you can just hit enter at that point. And this says round to the nearest tenth of a degree. There's tenths, that's 5 or bigger, so it's 46.7. X is equal to 46.7 degrees. Okay. Next. Should be the last one, so hang tight. SOHCAHTOA words. This is your opposite. This is your adjacent. That's tangent. So the tangent of that angle is equal to your opposite over your adjacent. I want tangent to go away, so I'm going to inverse tangent both sides. I don't know why I'm writing it above like that. It kind of gives like the impression that let me put it in front. It should really be in front. Not really taking, that's not times, that's misleading. Okay, you're taking it of that side. Let me change color. You're really taking this of both sides. So inverse tangent, I can't squeeze it in there, so that's why this one I'm going to write above. These two cancel out. I have x is equal to inverse tangent of 95 over 75. Just grab your calculator, type it in, second tangent, 95 divided by 75, 51 point, and it said tenth of a degree, 51.7. 51.7 degrees. Okay, I think that's the last screenshot. If you guys have questions, I'd love to see you in office hours. Take care. Be well. Be safe.